Yes, a good morning to all of you, dear students. Yeah, in our last lesson, we looked at the introduction of matrices. We're able to look at how to add, how to subtract, and how to use a scalar as part multiplication. I gave you some work, which I hope you tried out, and I expect that you got right by applying those principles. Today, allow me to take you through multiplication of matrices. And we shall consider two matrices. That if I have a matrix A, 1 by 2, 3, 4, and another matrix B of order 5, 6, 7, 8, and we are told to multiply by finding AB, we shall be able to do this multiplication by following the order. Our AB will be 1, 2, 3, 4 times. We don't need to indicate the times symbol. We simply arrange the working and proceed. Matrix multiplication, we shall discover, may not depend on the order being consistent, much as we are trying with a consistent order. This will be able to give us, we get row multiplied by corresponding column. So 1 will be multiplied by 5, and we shall add on 2 multiplied by 7. And here we shall have 3 multiplied again by 5, we add on 4 multiplied by 7. Then for the next term, we shall do the same. 1 by 6 plus 2 by 8, and again 3 by 6 plus 4 by 8. This will now be computed to give us the final answer, which is 5 plus 12, giving us 19. Then 6 plus 16, giving us 22. 15 plus 28, giving us 43. And 18 plus 32, giving us 50. This will therefore give us a final answer as 19, 22, 43, 50. It is important to note, as the first example, that A and B as matrices have the same order. Have the same order, which is a 2 by 2. They are all a 2 by 2. And generally speaking, we can say that for matrix multiplication, the orders of two matrices may not necessarily be the same. We can say that for multiplication of matrices, order of given matrices does not necessarily need to be the same. This is very important. It does not necessarily need to be the same. As I can show you, if I have a 1, 2, 3, 4, 5, 6, I can multiply it by a 7, 8, 9. And my answer would be 1 times 7 plus 2 times 8 plus 3 times 9. And 4 times 7 plus 5 times 8 plus 6 times 9. This will lead us to an answer of 7 plus 16 plus 27, which will give us 50. 28 plus 40 plus 54, which will give us 122. This can now lead us to a conclusion that the orders of mother matrices of mother matrices for this question are, as you can state, row, there are 2 rows by 3, and then 3 by 1. Those are the orders. Given that these are the same, the result matrix, which we have just got, of 50, 122, is of order 2 by 1, which you can see here is of order 2 by 1. So matrix multiplication, therefore, can always be possible. In conclusion, we can say that if P is an M by N matrix and Q is an N by K matrix, then we can say P times Q is possible. P times Q is possible, and we'll give an answer of the order which you can get from M by N times N by K. This, which is common, will be the same, as you can see, and the result, if I called it Z, will be of an order. Z will be of an order that is remaining, M by K. In other words, I'm saying that P times Q is equal to matrix Z, and P is an M by N, then Q is an N by K. This part that is the same will die to give us the matrix Z of that order. Therefore, matrix multiplication does not necessarily depend on the order of matrices. Does not necessarily depend on the order of matrices. You can look at another example, and then I give you an exercise. We can consider a matrix like A. If A is 3, 4, 5, 6, and B is, say, 2, 4, 1, and 1, negative 2, 3, we can find matrices. We can be taught to find, for example, part 1, A squared. A squared will be A times A, which will be 3, 4, 5, 6, multiplied by 3, 4, 5, 6. And when we compute this, as we said, we shall get the first row multiplied by the first column. We shall get the first row, 3 times 3 plus 4 times 6. Then we shall get the first row multiplied by the second column, 3 times 4 plus 4 times 6. This should have been 5. Then we shall have 5 times 3 plus 6 times 5 and 5 times 4 plus 6 times 6. When we compute this very well and add within, we should be able to get a final answer. This is a 3 by 2 times, 3 by 2 times 3 by 2 will give us our final answer of 3. This is 9 plus 20, which is 29. This is 12 plus 24, which is 36. This is definitely going to give us 45, that is 15 plus 30, and this will give us 20 plus 36, and that will give us 56. So our final answer becomes that this is still multiplication, So the candidate should be able to know that it is A times A. If we proceed, we could be given another number, the same matrix, and they say find A times B. Our A times B is, we shall have our A as 3, 4, 5, 6, times our B, which is now 2, 4, 1, and 1 minus 2, 3. We shall compute this using the normal multiplication, as we have said. We get 3 times 2 plus 4 times 1. We shall get 5 times 2 plus 6 times 1. Then we proceed through the same. 3 times 4 plus 4 times minus 2. We can still use 5 times 4 plus 6 times minus 2. Then we can still use 3 times 1 plus 4 times 3. And again, we have 5 times 1 plus 6 times 3. What is important is that the candidates can note that the order of the final matrix we are looking for is a 2 by 2 times a 2 by 3. So the final result should have a 2 by 3, as you will shortly notice. That when we compile and compute this, it will be able to give us our answer as a 10, that is 6 plus 4, 12 minus 8, that is negative 4. This 12 minus 8, that's positive 4. Then we have 3 plus 12, that is 15. Then we have 5, which is 10, that is 16. 20 minus 12, that is 8. And finally 5 plus 18, which is 23. So we shall get our final answer, our AB, as that. We could be asked also to go ahead and find BA. This is very important. Find BA. Yeah, to find BA, we shall test the orders. That B has an order of a 2 by 3 and A has an order of a 2 by 2. Since this is not the same, it implies that BA is an impossible matrix. It is incompatible. It is incompatible and therefore hence not possible. Not possible. In some cases, they can ask you to state whether the multiplication is possible or impossible. If the interior part of the orders is different, candidates or other students following this lesson should note that that will be impossible. That multiplication will be impossible. They can also give you to find, say, A cubed. You should know that this is A times A times A. And this is the same as A squared, therefore, times A. Why? Because